Last and final lecture here of the course. So we're going to finish up with talking about human-induced climate change. So to start off, I have a couple quiz questions for you. So I am curious which of the following of the choices that you have on there are closest to your personal view of global climate change or global warming. And then the second question, which of the following statements reflects your view of when the effects of global warming will begin to happen? All right, so I'm just curious about these two questions from you. So this is what I ended the last lecture with, was a slide showing that climate hasn't really changed, or hadn't really changed from the year 1000 up to about 1850. And then once the Industrial Revolution started, we have evidence from thermometers, which is in red, tree rings, coral, ice cores, historical records, which is in blue. We have records of temperature, global atmospheric temperature, on average increasing since 1850. So in order to understand climate change, we need to just kind of recap the greenhouse effect again. So the greenhouse effect is the idea that any radiation from the sun travels to Earth, and then it might reflect and get re-radiated back up into the atmosphere. Some of the heat escapes into space, but if you take greenhouse gases like carbon dioxide, nitrous oxide, and methane, which I'll define those here in a minute, and you add more of those to the atmosphere, then we can get a human enhanced or human induced greenhouse effect. So the amount of radiation from the sun does not change, but what happens is that as radiation goes back up into the atmosphere, it stays in the atmosphere longer, and by staying in the atmosphere longer, it heats up the atmosphere more. So you have a human enhanced greenhouse effect that occurs when you have more greenhouse gases that are emitted into the atmosphere. So greenhouse gases absorb radiation and they heat the surface. So there's a couple greenhouse gases that we worry about. There's carbon dioxide, or CO2. There's methane here, and then there is nitrous oxide. So for quiz questions 3 through 6, what you're going to need to do is look at the pie charts in the last slide. So those are all here for you. Question 3, which gas has the largest proportion of greenhouse gas emissions of those 3 gases? 4, which sector is responsible for the largest proportion of greenhouse gases? Question 5, considering carbon dioxide emissions, what sector emits the most CO2? And then finally, question 6, what sector is responsible for the largest amount of methane and nitrous oxide emissions? All right, so feel free to pause and come back when you're ready. So you have more questions now. You have a table here, table 17.2, that's showing you the global warming potential for greenhouse gases. So we have carbon dioxide, methane, and nitrous oxide, and then their atmospheric lifetime, and then what we call their global warming potential for 100 years. So question 7, which greenhouse gas is of the highest concern in terms of global warming potential? And then question 8, how much of the global greenhouse gas emissions come from China and the US combined? So if you look at greenhouse gas concentrations in the atmosphere, what we notice is that they keep increasing. So carbon dioxide keeps increasing, methane keeps increasing, and nitrous oxide keeps increasing. So post-industrial revolution, these concentrations of these 3 gases have just been steadily increasing in our atmosphere. And if we overlay, so in terms of the argument of this, is this human-induced or is this natural climate change? If we overlay the emissions that come from humans, that's in blue on this time frame here from 1850 to 2010, that's in blue. And if we look at atmospheric concentrations of carbon dioxide, so that's red here, what we notice is that they match up. So as humans are emitting more into the atmosphere, the concentration of CO2 in the atmosphere is going up. So I like this figure here because it tries to separate human and natural influences on climate. And if we only use natural factors such as like volcanoes erupting as an explanation for the change in global temperature, what it would show is that the temperature should still stay about the same and not really go above a change of more than 0. So it would kind of just stay the way that it has been throughout history. But if we look at natural and human factors and combine them, what we noticed is that that is what drives our model in terms of global temperature change more to the positive direction, meaning it's getting hotter and hotter on Earth over time. So the point here is that models and data show that it can't just be natural factors alone. We have to consider humans as an explanation for why temperatures are increasing. Let's talk about the evidence. So we're going to go through, I have a lot of graphs to show you over the next couple slides. So we're going to talk about evidence for climate change already happening right now. So loss of Arctic sea ice. There is up in the Arctic Ocean, there is sea ice that typically covers the surface of the ocean in the summer. But summer sea ice is now less than 50% what it used to be back in 1979. So the thing that's playing through here on the left side shows you the edge of sea ice in the 1980s and then working its way up to the present day in terms of the extent of the sea ice coverage. Ice melt also occurs 3 weeks earlier now than it did in 1979. So loss of sea ice also means the loss of animals that are dependent on sea ice, such as polar bears. Just to give you one example, this is down in Antarctica, so in the southern hemisphere, the South Pole, but between February 4th and February 13, 2020, the temperature in Antarctica reached 65 degrees Fahrenheit, which was the highest temperature ever recorded down in that part of the world. And 20% of the snow on this specific island, which is near Antarctica, called Eagle Island, melted within 9 days of this, during this 9-day heat wave. So we have a before and after playing through of all the ice that melted in the snow. If we look at temperature data, so we have loss of sea ice, we also have temperature data from 2000 to 2020. 19 of those 20 years in that 2-decade period were the warmest one on record, and basically every progressive year that we keep having breaks the global temperature record. So each progressive year that we have is getting hotter and hotter. So for example, summer 2023 was the hottest on record, but maybe summer 2024 will be the next hottest summer on record globally. If we look at July, just July temperatures, what this graph down here is showing you, if it's 0, that means that it's normal. If it is less than 0, that means it was colder than normal. And if it's more than 0 in the red colors, that means it was warmer than normal. And summer 2023 was 1.1 degrees Celsius warmer on average compared to historical averages. So each progressive year, it keeps getting warmer and warmer and warmer. Just showing you this same data another way. So the lighter the color, the closer the data was to 1850. The darker the color, the more present day it is. So if we're looking at global mean temperature by month, if we look at every single month, basically all across the world, temperatures are warmer in every single month than they were at any other point in measured historical records. So, in addition to temperature rising, the rate of increase has become faster in the last 25 years. So, if we look at the general trend in red here over the last 150 years, we can see that the Earth was warming at 0.045 degrees Celsius per decade. But if we look at just the last 25 years, you'll notice that the slope of this line is different, and it is now at 0.177 degrees Celsius per decade. So not only is Earth getting warmer, it's getting warmer faster, and that rate keeps increasing in modern times. So I just have text on this slide, but what's other pieces of evidence? So if you have a warmer temperature, you get heat waves, you get droughts, you get melting ice, you get extreme floods, because severe storms can pick up more moisture and evaporate more water from the ocean or from lakes. And then you get stronger storms, so you get more extreme flooding because of that. Drought, I already mentioned, and then you get wildfires in places like California and the Amazon and Australia. So the warmer the temperature, the more extreme kind of weather-related impacts that we have related to those increased temperatures. Other evidence includes increasing ocean temperatures. So if the ocean is getting warmer, which we know it's getting warmer, when you heat water, water expands. So by heating water, you expand water, and the result of that is sea level rise by heating water. So what data has showed is that down here we have 1850 up to the year 2000. And then we're looking at the global average sea level in terms of its difference from a time period from 1961 to 1990. So if it's above zero, that means that sea level is rising faster. And then if it's below zero, it means it was rising slower. So sea level has increased by about 6.7 inches or 0.17 meters since the year 1900. And then right now, currently, the sea level rise is about 3.4 millimeters per year. All right, so if we look at more evidence of changes in weather patterns, so changes in weather patterns are seen as evidence of human-induced climate change. There's certain areas that are getting more dry. There's certain areas that are getting wetter. So the figure that is down on the bottom here, though, is showing where we have the weakest evidence of this being caused by climate change. So tornadoes and thunderstorms, we don't really think of as being as strong of evidence for human-induced climate change. As you go to the right side of this figure, this is the strongest evidence for being caused by human-induced climate change. So drought, parched soil, high tide flooding, increased storm surges when you have hurricanes and floods, extreme heat, and extreme rainfall from hurricanes. All of these scientists think are extremely linked to human-induced climate change. So when we do look at changes in weather patterns, so places like Africa, the Mediterranean, and South Asia are getting drier. Places like New England, Eastern US, and then South America and Central Asia are getting wetter. So using the graphic on the last slide, this one here, your next quiz questions are which of the following would be considered a weak piece of evidence for climate change, and then which of the following is considered a very strong piece of evidence for climate change. So I just want to finish up with talking about climate models and predictions for the future. So climate models are the way that scientists try to make sense of all the data that we have available to us and then make predictions into the future about what the future might hold in terms of climate change. So climate models divide Earth's surface into a grid, and then basically you input a bunch of data into each grid cell here, you spit in, run a model, and then it'll spit out some data and tell you if it's expected for that place to get wetter, drier, warmer, colder, out into the future. So what do models say? Typically, they're run under a range of scenarios. So there's usually a high growth scenario, there's a moderate growth scenario, and a low growth scenario in terms of emissions. So the International Panel on Climate Change, or the IPCC, makes it clear that even if we stopped emitting carbon dioxide and greenhouse gases altogether overnight, which would not happen, Earth is still going to warm about 0.4 degrees Fahrenheit per decade for at least the next 15 years. But that's assuming that there is not that everything is solved overnight with no emissions. So that's not going to happen. So typically, then models are going to do different scenarios of low growth, moderate growth, high growth, which would be worst case scenario in this scenario. Here's what they show, so they can predict out into the future. So this is 2046 to 2065 under different growth scenarios. So this would be a moderate growth scenario in 2046 to 2065, and then 2080 to 2099 in terms of moderate growth. The temperature is the colors here. So the warmer purples, reds, oranges are going to be warmer temperatures, and then the blue is colder temperatures relative to today. Under a high growth scenario, projecting out into the future up to 2065 and then up to the year 2099 here, the purple colors indicate that the Arctic is supposed to have the highest degree of warming. So at the northernmost latitudes, some models project or predict that it will warm by 14 degrees Fahrenheit in the northern latitudes relative to today's temperature. Snow cover will continue to shrink. Arctic ice will disappear completely, as well as all of the organisms that depend on Arctic sea ice in their ecosystem. And then global sea levels might rise between 8 and 20 inches, depending on a moderate growth to high growth scenario. This is models for precipitation. So this is looking at relative to December to February of 1980 to 1999. So we're looking at winter months, and then we're looking at summer months. So this is model projections out to the year 2100 And it's basically saying that in winter, if it's red, it's going to be more dry. If it's blue, we're going to have a wetter winter in those areas. And then in summer, red means drier than right now. Blue means wetter than right now. So what did the model show? Deserts that are at 20 to 30 degrees north and south are going to expand. The equator will get more rainfall. The poles will get more rainfall. And then there'll be increased severity of storms due to new extremes. All right, so if you want to read about some of the effects on Earth systems, this kind of breaks down the effects of climate change by each degree temperature rise. So at 1 degree of Celsius of temperature increase, 2 degrees, 3, 4, and then worst case scenario, 5 degrees Celsius of increase on the right side. It breaks it down by hydrosphere, ecosystems, food, coastlines, health, and singular events. And if you want to read about the predicted changes to Earth, you can look at this slide in a little bit more detail. So let's talk about what can be done. There are international climate agreements like the Paris Climate Agreement. The US withdrew from this in 2017 and then we rejoined it. And then depending on what administration is in power, usually we're either in it or we're out of it. But the Paris Climate Agreement was a global agreement to try to keep the amount of warming on Earth to under 2 degrees Celsius average, global average. So let's just talk about other things. And I realize some of this might seem a little bit preachy. So what can be done to reduce greenhouse gas emissions? Transportation is one of the largest sectors in terms of emitting greenhouse gases. So if you improve efficiency and then energy conservation, that would be a way to help reduce greenhouse gas emissions, but that requires kind of sweeping legislation and building codes and changes in large industries and corporations that would have to be done. So this could be anything from improving fuel economy even more, or just investing in electric cars. So as of now, there's like 9 states that have said that they're going to ban or phase out selling gasoline cars by the year 2035 in the US. California was the first to say they would do that, and Massachusetts is a state that's also said that they'll phase them out. Reduce reliance on cars, energy efficiency improvements, as well, and changing fuel sources for power plants. So there's changes in electricity sources, investment in renewable energies, wind, solar, that would help offset the emissions that come from burning coal, oil, natural gas. Replacing coal power plants with natural gas. Coal is now less of an energy source than renewable energy in the US, so that's kind of shifted a little bit. And then also change transportation energy sources. So hydrogen fuel is a field of development, carbon capture, and biofuels. One other proposal is trying to increase ways of storing carbon in either living organisms or in soil. So trees store a lot of carbon, and if we cut down trees, then we've lost all that carbon storage or that sink of carbon. So stopping deforestation, but also replanting trees in a smart way to keep carbon coming out of the atmosphere, and then being careful about how we farm. All right, and then the last kind of preachy thing here is like, what is your personal lifestyle? So what can you do in your personal lifestyle? I like this figure here because it basically shows you what has the highest impact in terms of your carbon output. So that would be living car-free or flying. But as you go down the steps here or down the scale here, these are the ones that have the lowest amount of impact because a lot of impacts are from power plants, transportation, corporations, industry, rather than your personal choices. So for example, avoiding buying plastic, home waste recycling, and turning lights off is not as efficient as many other things that you could do to try to reduce your own personal carbon footprint. Okay, so to finish up this in the course, so I want you to reflect on this lecture. So in your opinion, how do you feel about climate change? What should we do about climate change? What can you personally do about climate change? And has your opinion changed after taking this class and listening to this lecture? I also want you to reflect on the course as a whole. So do you have any final comments or feedback for me? So this is the first time that I've taught this course as a summer online course. So I'm open to any and all feedback that you might have on the course. So feel free to leave me some suggestions. All right, and thank you.